Dear students, welcome to another lecture on elements of machine design. Today let us discuss about use of design data books. You see, a machine designer, when he is designing machine elements or systems or any machine products, he needs a variety of information, and this information is like the materials, about the materials, their properties, then what is the design procedure at various as per various national and international standards and codes. What are the standard sizes available? What are the standard shapes of the components, like screws, bolts, nuts, circlips, and similar things, and standard sizes and load ratings of standard components, and about the bearings, chains, belts, ropes, and what are the different types of fits and tolerances, and the values of various types of stresses, surface finish, and all these things he needs to know. So for this purpose, you see, he has something called as designed data book. So this gives him an advantage, so that all the information that is necessary for him is consolidated in one place, and it is available to him, that is the design engineer, so that he need not be looking for information here and there every time. It is available in one place, and it is in the form of a book that is called as design data book. You see, in India we have so many resources available, which are used as data books. These resources examples, see, Shigley, Shigley's mechanical engineering design, which is published by McGraw-Hill's, and you have Dudley handbook of practical design, and you have IS code IS 2825, which was published in 1969. This is used for pressure vessels and similar such as national standards. National means our country India standards, and international standards and codes are available, you see, and these standards we can refer, and also manufacturers catalogs. For example, if you are talking about bearings, you see, uh, SKF company, they have their own catalog of ball and roller bearings, so those things also we can use. And we have charts also, for example, charts of theoretical stress concentration factor, KT, and such information also, uh, and then technical journals are available, example ASME journals, and so many other international journals and national journals which are available, which the researchers or people who are doing PhD and post PhD, post doc and all, they'll be publishing so much of material in the journals, and those things we can refer. But some of these things, in India we use something called as PSG data book. PSG is an engineering college, aided engineering college in Coimbatore. Those, the faculty there, that means the professors there, they have compiled one design data into a book form, and they are calling as PSG design data book, that is available in our library also, that we can use for designing data. So when I was studying in in an undergraduate level, that is when I was doing BE in Nagpur University, we were using a design data book which was made by Shevalkar. So it is a small book. It was called Shewalkar's Design Data Book, and that we were using. That we were using in Nagpur University. But throughout India, what is more famous is PSG data book. Okay, this PSG data book, which was published by the professors of PSG Engineering College in Coimbatore. This is more popular. This is available in our library, and we can use it. Okay, so that is the use of design data books. Everything, consolidated information about all those things is available in one place. Okay, now coming to standards. We talked about Indian standards. Standards can be, many types. What we were talking was about national standard, and to some extent we touched some international standard. But standards can be, it depends upon the defining body who is making these standards, or who is that organization who are making these standards. You see, if a company makes standards, one company, if they are making a standard, it is called company standard, and it is followed by that company. You see, if you take Mahindra and Mahindra company, when they are producing these jeeps, tractors and all these vehicles, you see, they may have their own set of standards. You see, when there is need for company standards, when some national international standards are not available, then they may make their own standards. Otherwise, they will not be superseding some national standard and making their own company standard. They may have certain company standards, okay, which their companies will follow. The company means not only their plant in one place, like a company Mahindra and Mahindra in Nagpur. It can be in other places also. Wherever the Mahindra and Mahindra is there, that means all their plants in different places in India or abroad, wherever, and they may follow, and even their sister concerns may follow. Not only their company, their sister companies. That means, if the management is same, their sister companies also may follow if they are company standards. Then national standards, like Indian standards, which are framed by Bureau of Indian Standards. It is followed by all in the country, in the nation. Okay, national standards are used by people in the nation. Okay, and international standards are used by uh, uh, used throughout the world. There may be few very small companies, countries, they cannot afford to have their own standards. They all follow international standards. And also those companies which which um, which want to trade with other companies, import export business and other things they are doing. Okay, those people will have to follow international standards. Okay, see in detail here it is given. Company standards are defined or set by a company or a group of companies for their particular use. National standards, these are defined and set by national apex body. Apex body means top body, normally followed throughout the country. For example, BIS, Bureau of Indian Standards, this is followed in India. ASME, this is American Society of Mechanical Engineers, uh, followed in America and so many other countries also. American Gear Manufacturers Association, AGMA, American Welding Society, AWS, American National Standards Institute, ANSI. Okay, these are some of the standards, which are national standards. Okay, and international standards, these are defined and set by international apex bodies, international top bodies. uh, Actually all the countries have come together and they have formed United Nations, which is called UN. Okay, this UN, under that so many other bodies are there. So they form this thing. They are normally followed all over the world. And the examples of standards prepared by these apex bodies are International Standards Organization, ISO. See, this is in so many things, we follow ISO, international standards organization. See, if it is only IS, it is called Indian standard, but it is ISO, it is International Standards Organization. And then International Bureau of Weights and Measures, IBWM. You see, this is another international body. So some of the standards are advisory. Advisory means, it is not necessary to follow in nature and are used as guidelines. Whereas other, especially those set by national and international organizations, are obligatory. Obligatory means compulsory. Some are advisory in nature and some are obligatory in nature. Some are only, for a suggestion they are giving. It doesn't matter whether you follow or not. Some are obligatory, that means you have to follow, and sometimes they are enforced by law of that country. Okay, so these are the international standards. So three types of standards we have seen. Okay, okay, now let us come to the next topic, theories of elastic failure. I say this is another important topic. Not so many times, you can see how many times it is asked in the exams. Okay, so you see, theories. These are the theories. Initially, some scientists, or we can say engineers. Okay, okay. Rather, we let us say scientists. These people have made some theories. Maybe when a failure is occurring, why this failure is occurring? Maybe it is because of this it is occurring. Okay, you see, there are number of components, machine components, that are subjected to several types of loads simultaneously at the same time. There can be combined stresses induced in it, like torsional shear may be there, bending may be there, direct tension may be there, shear stress, transverse shear may be there, you know compression also may be there, and like that, so many stresses may be there acting on a component. So when that component fails, the failure of such components are grouped into two groups, classified into two groups. What are they? They are elastic failure and yielding and fracture. See, elastic failure results in plastic deformation, which, you see, which deformation which makes the machine component unfit to perform its satisfactory. That means elastic failure means it has crossed its elastic point, elastic limit. So that means what? It has yielded. You see, it has become longer, and where it should fit, it is not fitting. So it is treated to be failed. Okay, and it is unfit to perform its function satisfactorily. That is one failure. The See, the theories of elastic failure provide relationship between the strength of machine components subjected to complex state of stress. You see, when you are talking about failures, see, actually, no, they have written here like this: elastic failure and yielding and fracture. I think these two are the same, failure by yielding. The second one is, or we can say it is a ductile failure. The other one is a brittle failure, like, cast iron fails in brittle manner, and mild steel fails in ductile manner. So ductile failure and brittle failure. Okay, it can be like this. Okay, in these books they have written like this. Okay, now coming to the theories of failure. Theories of failure. See, uh, they are a certain number. I think 4 or 5 numbers are there. Okay, let us see the first one. First one is maximum principal stress theory. This is Rankine theory. So who is Rankine? Rankine, as you can guess, maybe that scientist who has proposed this theory. So Rankine theory, what it states, okay, this theory states Okay, and it is working for brittle materials. You should remember this theory, maximum principal stress theory, works for brittle materials. And this theory is stating, this is the definition, that means from here onwards, that elastic failure occurs when the greatest principal stress reaches the elastic limit value in simple tension test, irrespective of the value of other two principal stresses. You see, we have three principal stresses as we have seen before: maximum principal stress, minimum principal stress, and maximum shear stress. Out of this is maximum principal stress theory. That means this maximum principal stress, if it reaches the elastic limit, reaches means reaches and crosses. That is the meaning. In a simple tension test. So what happens? Failure occurs. Failure occurs. So that is the definition. The definition states, this theory states that the elastic failure occurs when the maximum principal stress reaches the elastic limit in a simple tension test. You can stop here, or you can write this also, irrespective of the value of other two principal stresses. Okay, so you see, suppose Fs is the factor of safety, then sigma T is equal to sigma ut upon Fs. Actually, this we are considering for brittle materials only. So only brittle materials we should see. Okay, sigma T is ultimate stress upon factor of safety for brittle materials. This becomes the criteria where this maximum principles theory applies. Okay. Okay, coming to the second theory of failure. This is maximum shear stress theory. Okay, it is also called as Guess or Tresca's theory. Okay, depending upon those people who have thought about this theory, proposed this theory. Okay, what is this theory saying? You see, here it is written, this theory is used mostly for brittle ductile materials. First one we have seen. First one, the maximum principal stress theory, is used for brittle materials. The second one, maximum shear stress theory, it is used mostly for ductile materials. Okay, but anyway, what does the theory say? When a component fails. When does a component fail? You see, that is what this theory is saying. This theory is saying, or this theory states that the elastic failure occurs, elastic or yield failure occurs at a point when when the maximum shear stress in the biaxial stress system reaches value equal to the shear stress at yield point in simple tension test. You see, here also we talked about simple tension test in the first thing. Second thing also we are talking about simple tension test. Okay, and what stresses we are talking here, though it is not mentioned that it is biaxial stress system. So in the first also it is biaxial stress system only. We know that there are three principal stresses. One is maximum principal stress, second is minimum principal stress, and the third is maximum shear stress. Now first theory talked about the first stress, that is maximum principal stress. Now the second theory is talking about maximum shear stress. So when this maximum shear stress produced in a component, in a member, component or member or element, whatever you say, Okay, in a member, when this maximum shear stress reaches the value equal to the shear stress at yield point, then this component fails. You see, in the first thing, what did we say? This fails when the principal stress reaches the elastic limit, then it fails. Here we are saying, when the maximum shear stress reaches the shear stress at yield point. In the first thing, it was reach, what point should be reached? Elastic limit should be reached. In the second, what we should be reached? It should reach the shear stress at a yield point. You see, in yield point, what stress you get is uh, tensile yield stress. But we are talking about shear stress. Okay. See, at the yield point, how much ever is the shear stress, if that is reached, then this component fails. And mathematically, we can give like maximum shear stress, that is tau maximum, is tau yt. Yt means, this is yield point, and tau is shear stress. Yield point shear stress divided by factor of safety. Okay, so tau yt is given here, shear stress at yield point, and tau maximum is maximum shear stress. Okay, and sometimes in the data books and other things, you won't get this value given. Instead, what value will be given is yield point stress. Yield point tensile stress will be given. So tensile stress is given by sigma. Shear stress is given by tau. So tau stress may not be available of yield point. And tensile stress at yield point will be available. Therefore, this formula can be translated as like this: sigma yt upon 2 factor of safety, 2 times the factor of safety. That means what? Shear stress at yield point is taken to be one half of the yield stress. That means yield stress, whatever is there, yield stress is 200 Newton per mm square, means yield shear stress should be taken as 100. That is the meaning. Okay, like that you have to take and calculate. So this is the second theory of failure. And the third theory of failure is called as maximum principal strain theory. This is not stress, here strain. Okay, maximum principal strain theory, this is also called Saint Venant's theory. Okay, what does this say? This says that the elastic failure, or yielding failure, occurs in a member when the maximum principal strain in a biaxial system reaches the limiting value strain determined from a simple tension test. You see, in a simple tension test in a UTM machine, you have determined for that material. They see at yield point, the see uh, for max. Okay, okay. From yield point, this will be the stress. Okay, and for ultimate tensile stress, this is the stress. We find out stresses at various places. Elastic limit is this, then the yield point is this, and the ultimate tensile stress is this, breaking stress is this. What is the maximum strain that is coming in the component. So when this maximum principal strain theory says that the failure occurs when the maximum principal strain induced in that member that reaches the limiting value of the strain determined in a simple tension. Limiting means the ending, you can say the ending value. Okay, like that. You see, strain is given by and this epsilon, what is this epsilon? Okay, maximum. So that is equal to uh, okay, some sigma t1 upon capital E minus sigma t2 upon me, like this. You see, you need not to memorize this formula. What is needed is only just the definition of it is needed. Okay, and um, okay, that much only you remember for this theory of failure. Next theory is maximum strain energy theory, or it is also called as Hayes theory. This is strain energy. First is maximum principal stress, second theory is maximum shear stress theory, third is maximum strain theory, fourth is strain energy theory. Okay, so strain energy means the energy that is stored in the component. So what is this theory saying? See, this theory is saying failure occurs in a member when the strain energy per unit volume in a biaxial system reaches the limiting strain energy per unit volume in a simple tension test. You see, in a simple tension test, you have calculated and saw this is the maximum strain that can be stored in that type of material per unit volume. So you remember, if that maximum energy is reached, then the failure occurs. That's what it is saying. You see, in the previous thing, also, this is the maximum strain that this member can occur, this material can withstand, and this it was determined, and that maximum strain is reached. So failure occurred. Here, here they are saying in a simple tension test we have found out for this material, this type of material, this is the thing. By a test specimen we experiment and see, and we have determined this is the maximum strain energy that can be stored per unit volume. Okay, and in your member so much energy is stored, and then the failure occurs. That is the meaning. Okay, you see, we need not go through these equations and all. Okay, now this is again used for ductile materials. Okay, and you see, you can say the first one is for brittle materials, and all the others I see, they are all for ductile materials. Okay, then the last one is maximum distortion energy theory. This is Henke or von Mises theory. So this is a distortion energy. First one is maximum principal stress, second is maximum shear stress, third is maximum strain, fourth one is maximum strain energy, fifth one is maximum distortion energy. Okay, this theory says the failure occurs at a point in a member when the distortion strain energy or shear strain energy per unit volume reaches the limiting distortion energy per unit volume in a simple tension test. Okay, you see, the simple tension test has determined that this material can have this much is maximum distortion energy per unit volume. Okay, if that is reached in this material, then failure occurs. That's what this is saying. So this is also used for ductile materials. See what I have seen, I told you only the first one is used for brittle materials and all the others are used for ductile materials. Okay, this much is for today. We'll stop here. Thank you very much.